All right, welcome to chapter 9. We're going to talk about queries and what you can do with them to isolate data, where you ask the data a specific question, you get back an answer, and you can take that answer and either use it for something, like an analysis type thing, or maybe as an intermediate step towards something else. So there's lots of things you can do with queries. There's several types of queries we're going to talk about. Very, very powerful technique to get at a very specific data set that you might need. All right, so what is a query? Well, in a nutshell, a query is asking the data a question and getting back an answer. Now, assuming you ask the question correctly, you should get back the answer you hopefully expect. So it's one of those things where you're going to extract a subset of features based on a condition. So you ask the question, for example, in the slide here, give me all of the counties that have a population greater than 100,000. So that's a very specific question. You're going to get back just those counties. You also have spatial queries that test spatial relationships, such as give me all of the parcels that lie within a floodplain. Again, that might be for insurance purposes. So we're going to discuss both types of queries in depth here, both an attribute query where you're asking the table a question and getting back a selected set of records. And we're also going to look at spatial queries where you're comparing two completely different um, layers, and they could be of different geometries, to figure out if there's some type of correlation there in space that maybe you hadn't seen before. So it's a very, very something you're going to use a lot, and especially sort of in the pre-processing steps of a further analysis. It's a way of whittling down the data, which is a huge part of what you're going to do in GIS anyway. You never need all of the data. You usually need a subset of the data that's going to tell you, give you the answers that you need. And then you have to ask those questions, sort of pluck out what you need, and then use it towards a greater good. All right, here's some examples of queries that you could do. Something like selecting features of interest. Give me all the wells that have high iron concentrations. Because once you ask that question, you see those points highlighted on a map. Now you could start to make some assumptions or conclusions based on where they sit in space. Is there some type of pattern going on that maybe you wouldn't have seen with the naked eye until they were highlighted on your screen? So it's a very rudimentary type of selection, but at the same time, if that's where your analysis is going towards, that has to do with high iron concentrations, this is a first step, is to isolate those with high iron concentrations, and then maybe from there take that and springboard it into something such as what's the geology that the predominant geology they sit in, does that have something to do with the high iron concentrations? So it kind of piggybacks. You got to start somewhere, ask sort of that broad question, and then hone in from there based upon other criteria, other layers, and things like that. You could look at spatial patterns such as gold mines versus other mineral mines. Okay, so you're sort of comparing where things are. Again, looking at, are there patterns in space? Are they clustered, at least visually, not statistically, not using a cluster tool, but just visually? Hey, are all the gold mines sort of clustered in this area or that area? Do they form along certain lineaments? Uh, Linear features, excuse me, let's say a fault or some type of contact. So that's another thing you can do. You can isolate features, like I mentioned. This is it's sort of what a pre-processing step, I call it. You need to take the data that you need specifically for your project and isolate it. It's just something you have to do in GIS. There's no reason to carry around a large data set if all you need is a small portion of that. Just a silly example, there's 50 states. If all I care about is Wisconsin, why do I want all of the other 49? So I would select Wisconsin and then take that and export it into my geodatabase so I don't have to carry around all that other bloat. So that's a huge part of what you're going to do with selection methods. Then we also have exploring spatial relationships, and we just mentioned this. We'll get to this a little bit later. These are the spatial queries, such as where roads might cross a limestone outcrop, or pose a groundwater hazard, things like that. You're comparing two completely different data sets based upon various criteria in space, whether they intersect each other, is there a proximity or distance? We'll talk more about that a little bit later. And you can use different geometry. So you can compare points to lines or lines to polygons or polygons to points. You can compare those. It just depends on how you're asking the question as to what kind of comparison you're going to use. Again, we'll talk about that a bit later. The final one is creating raster queries. Just like vectors, you can ask rasters a question. So a good example would be a DEM. I have a digital elevation model, um, and I need all of the cells that have a elevation value greater than 400 feet. Okay, so when I run that query, it's a yes or no answer. Either that cell is greater than 400 feet or it isn't. And so you'll get back sort of this yes no binary uh, raster back saying, okay, everything in here is true, everything in here is false. There's your answer. Now that may seem very rudimentary, but it's hugely this is how you do raster analysis and overlay, which we'll get to in the next coming chapters. So it's starting to add, the main thing for this chapter, for all of these types of examples, is just learning how to ask the question. Where do you ask the question? How do you ask the question? What are the different techniques for asking the question? But this is something in GIS that you do over and over and over again, because again, you never download the perfect data set because you probably are downloading way more than you need. All right, so here this chapter is about how to ask the questions. So there's a couple different kinds of queries. You have the interactive query. All right, so based upon records, okay, you can use, you can click on a map and select things. Click on the states west of the Mississippi River. That can be a bit time consuming. You have an attribute query, which we just mentioned in the previous slide, where you're asking the attribute table a question and it'll highlight the rows that fit that criteria or that condition. And so then you can gauge, did I ask the right question? Did I get back too much, too little? And we'll talk more about how to do that in a bit. And then you have spatial queries, which are spatial relationships between two layers, like I just mentioned. And again, the geometry doesn't matter. You can compare points, lines, polygons. So an example that would be a distance relationship. So let's say the cities are points, um, or and then you have earthquakes, and you can create sort of a buffer relationship. Give me all the cities within 50 miles of a major earthquake. Maybe you're looking at damage profiles or, federal funding or whatever it is. So you're comparing two very different data sets in space to figure out, is there a correlation there? Now, in order to do this, you're going to have to use some various operators, and a lot of this is pretty common sense. Maybe some of it might be new to you. You have the arithmetic operators. You can do math on these, because in terms of a lot of times that's done in raster world, but you can do 3 plus 5 type stuff. You could take an entire raster that might be in centimeters and just using the conversion to inches. You can look that up online and just do the math, and it'll convert every cell to inches, that kind of thing. Um, you can actually you'll use logical operators, things like greater than or equal to, or less than, or greater than or equal, less than or equal to, that kind of thing. um, so that returns a true or false. So either it fits the criteria or it doesn't. All right, there's no middle ground. It's not maybe, it's yes, no, true, false. It's binary, which is really nice. So if I go state equals New Jersey, which you guys have seen already, there's only one New Jersey. That's the one that's going to be highlighted. Then you have GPA, your grade point average greater than 3.0. Well, there's more that it's not just 3, it's everything greater than 3. So you get a wider range of yes values, anybody who has that. So you could, depending on your class size. So the idea is you can make it very narrow, like the equals New Jersey, or you can make it semi-broad depending on what your needs are. Now, something that might be new to you are what are called the Boolean operators, and that's where you could really ask very specific questions. So with the logical operators, you have state equals New Jersey. You're always going to use the logical operators. But what you can do is you can have multiple criteria. So I could say, using this example here, I can say, give me all of the values where their major is geography and their grade point average is greater than 3.5. That's a very specific question. I'm isolating all the geography majors, but not only am I just isolating the geography majors, I'm isolating the geography majors that also have a grade point average greater than 3.5. So that's a very narrow search. Both of those criteria have to be met in order to bring back an answer. All right. So the idea is you can start to string these together with Boolean operators, and we'll talk more about those in a bit, um, in order to get a very specific question. Knowing how to do this saves time actually, so you can weed out all the stuff you don't need for your analysis. If you know exactly the data you need, it can make life a lot easier in terms of getting towards a further goal. And finally, we have the spatial operators, things like intersect, contains, and proximity, which we'll talk about in a bit, which allow you to ask those spatial relationships based on geometry, cities within 50 miles of a volcano, um, faults that intersect a specific kind of geology, things like that. We'll talk about that more in a bit, but those are hugely helpful as well. So we've already seen attribute queries a little bit. It's done with the select layer by attribute tool. Um, and it applies, it applies your condition and then it gives you back an answer. Assuming you ask the question correctly, you usually get back selected records. Okay. Now, if you don't get back anything, either you ask the question wrong or you just manage to figure out a way to ask a question that has no values in that particular table. And that can be a bit frustrating at times because you don't know whether or not you asked the wrong question or if that means probably the data set you have just isn't useful to you and you might have to go get a new one. So this is all done with SQL or structured query language. All right, so the structured query language allows you to very specifically ask those questions utilizing things like the Boolean operators. Okay, structured query language is ubiquitous. It's used all over the world in all kinds of database management systems. So we're using it in GIS. It's also used in MySQL. It's also used in Oracle or Postgres. Those are all database management systems of varying sizes, but they all use the same language, which is really nice. So if you learn how to write SQL, you can write SQL in GIS or you can write SQL in, let's say, Oracle. All right, now it's a bit more complicated in Oracle because you actually have to write this stuff, whereas in GIS they do a lot of the writing for you, which is really nice. So then you have the add clause in order to ask the question. So if we look at this example here, you have, okay, we're going to ask the cities layer a question. That's our target layer, so to speak. Which table are we going to ask the question of? Well, we're also going to, this is a new selection. We'll get more into selection types in a bit, but this is a brand new selection, meaning we're asking this question for the first time. Then you have to use the add clause button here to write your SQL statement. Now they've made this super easy in the ArcGIS Pro. It's even easier than it was in the previous version. So using the drop down menus down here on the bottom, okay, this field, the first one here, these are all of the attribute fields in the table. And we want the state of Arizona. So ST is the two letter designation, postal designation. So we go ST, this is our operator here, is equal to. That's what we want. Now you'll notice it doesn't have an equal sign. It says is equal to. And one of the nice things about that is in real database land, so to speak, when you got to write this stuff, equals and is equal to are two different things. 2 plus 2 equals 4. That's what when you're programming this stuff, one equal sign, if you just put one equal sign, it's 2 plus 2 equals 4. It's evaluating an arithmetic expression, for example. However, with something like this, where you're looking for a pattern matching type of thing, if you were to write this out in programmatically, that word's hard to say, it would be two equal signs, equal, equal. So it knows that you're looking for it sort of a text pattern. And in this case, the text pattern we're looking for is AZ for Arizona. So the beauty is in GIS, you do have to learn SQL, and the more you know SQL, the easier it becomes to really hone in on those questions. But just know that you don't have to be a programming wizard. It does a lot of it for you with these drop-down menus. And in fact, in Pro, like I mentioned, it's a lot easier even now than it was in the previous version. Not that it was hard, it's just even easier. Okay, so this is the SQL statement that you're writing. So when we're building SQL expressions, again, we're going back and we're actually having to um, get a very specific question. Now you can do it like I did in the previous slide with the drop-down menus, but sometimes you have to actually build it yourself. And we'll talk, this is how it's actually written in SQL. So if I use the SQL button and I click the expression box, this is the actual SQL, what they call the where clause. Okay, that's where you see this. The clause, it says add clause. In SQL land, you're building the where clause. So you're selecting features from a specific table. So it would be select everything or a star. Select star from the cities table where, you know, um, excuse me, the states table where ST equals Arizona if we went back to the previous slide. Now, there's different ways of, if it's much easier in most cases to use those drop-down menus, but sometimes you actually have to write the code. Now, you'll notice here, excuse me, the like expression here. We'll talk about that in the next slide, but this is one of those examples where you actually have to write a little bit of code. And when I say a little bit, you can see it there. It's not a lot. It's not a lot at all. So we need to go back and look at the Boolean operators because you have to understand how the Boolean operators work in order to get back the results you're looking for in your queries. So we have a bunch of them here, but just know this, we have 4 of them total, but almost always you're going to use the first two, either and or. The XOR and the not are very specific things. I've never used the XOR version ever. And I've been, I've written a lot of SQL. I've just never needed it for what I do. But the idea is the and the or, you have to understand how to read them in English, so to speak, or in SQL speak, because in English, we say it differently. So for example, if I say, give me all of the student majors that are majoring in English and they have a GPA of 3.0, that's how we would say it in English, right? Give me, give me all the student majors in English and GPA 3.0. However, if I put or in there, you're going to get a much different answer back. You're going to get everything back. Okay. We'll show those diagrams in a second. So one of the things that is a bit of a trips up people in the beginning is, do I use and or do I use or? And if you look at the second example here, you'll see student major equals Spanish or student major equals English. Now there's a couple things I want you to notice about these examples. So you'll see that student major equals Spanish, student major equals German. You have to repeat student major equals in SQL. What I mean by that is I cannot write student major equals Spanish or German. You can't do that. It won't evaluate, it'll just throw errors. You have to have the student major equals Spanish along with student major equals German. They both clauses have to be there in full for the SQL to work. Okay, that's the first thing. Now you'll also notice you're evaluating within the same table. So basically, let's say I have 50 different majors in this table if I want those two, in English we would say, oh yeah, give me the Spanish majors and German majors. Well, it doesn't work that way in SQL. In SQL, if you were to write that, you'd get back nothing because somebody can't be Spanish and German. They can be one or the other. Now, technically, I suppose you could, but for the purposes of this example, let's assume if you're going to be a Spanish major, they won't allow you to be a German major. Let's just say you can't do that. In English, we would say, oh yeah, give me all the Spanish and all the German. Well, that's, again, in SQL, if you want all of the Spanish and all the German, you have to use the or Boolean. So it takes a little bit of practice to kind of just wrap your head around, hey, this isn't English, this is SQL. It starts to make sense after a while. And the more you do this, you'll realize um, if you look at these down here, it says for the and, it says returns true if both conditions are true. And the or says returns true if either or both are true. Now I'm honing in on these two because again, the XOR and the NOT are very specific for very few applications. So the and, if you read that, both conditions are true. What that means is the and condition is very restrictive. In most cases, that's what you want. If you start asking your data a question, you have a very specific set of data you want back. The and Boolean operator is the way that you're going to get that. It's a very restrictive. I have some diagrams coming up in the next slides that'll show that. But that's the restrictive nature of the and Boolean. The or Boolean gives you back much more data, and in some cases, that is what you want. Like, for example, with the student major, I wanted all of the Spanish or all of the major, or excuse me, Germans. So I'm going to get all of those majors together. I'm going to get back a lot of data. Whereas the first example, I'm only going to get back those with English, but not just English, English and greater than 3.0. So it's a very specific group of data back. So let me repeat, and is the more restrictive of the two Booleans and typically is used for that very purpose to ask a very specific question and get back a very specific answer. Or is a bit more forgiving, but you do get more data back. But again, sometimes that is what you want depending on the data sets you're using and how you ask the question. Now, the XOR returns true if one condition is true and the other is false. Again, that's a very specific thing. And then not is if one of the first condition is true and the second is false. Those are very specific um, questions, and you have to have data sets that kind of work with those. Not as sort of getting back the false version. So if I have a bunch of ones and a bunch of twos, and I want back, you know, give me back everything but this, or give me back nothing but this. It's a weird situation, though. That's why they're just more specific and not used very often. So these Boolean operators are best described using what are called Venn diagrams, and hopefully you've seen this type of stuff and it kind of makes sense to you. So if I have a data set that encompasses all of this circle here, we'll call it T, table T. When I use the and between tables A and B, all I get back is what's sort of coincidental between the both of them. And in the previous slide, I mentioned that the and Boolean operator is much more restrictive. So you're only getting back that little bit of data. Whereas or, you're going to get, if I use the same, T's, you're going to get back all of this data. Again, sometimes that is what you want. But in most of my cases is for what I'm doing, it's usually using the and operator. So, and then these are sort of the inverses of those. So the XOR is sort of the inverse of the and, where you get back everything but what is coincidental. Again, very specific. And then the A not B or B not A type of thing. Okay. So it's going to exclude everything that's coincidental, but still keep the rest of it from whatever one you're using as your main data set. So here's some examples. I'm not going to dwell on this too much. If I have a whole table here, I can use uh, try to find overlaps between the students from New Jersey and geography majors. I could, look at everybody from A geography majors and, or if I look at CNA, I would say uh, students from New Jersey or geography majors. So there's all different kinds of combinations that you can use for this. But just take a look at the slide. I hope this all makes sense to you. Again, just going back, repeating myself yet again, and is restrictive or is less restrictive. And these Venn diagrams kind of show you how to do that. So this is where we would use, you got to start understanding which one to use. So if we have majors, we could say, give me all the majors of geography and state of New York. So what does that mean? So if that's going to give me everything here in this little shaded area. That's all that is going to give me back. Then I could say select students from either state. So that would be an or state, New Jersey or state equals New York, or sorry, New York and or new state equals. You'll notice that state here equals is twice. You have to have that. It's got to be there. And that would give me back everything in B and C. That would give me back all of the B and C here. Then select um, select majors from state equals New Jersey, not geography majors. So let me clear this here. Doop, doop. So state equals New Jersey, which is C, not geography majors. So that's going to be all of this area, I think. Oh wait, no, that's New York. I apologize. uh, that's going to be all of this. Sorry about that. Let's clicking on the wrong one. So that's where you're kind of excluding data, but keeping the original data set. Everything but geography majors from New Jersey. So here's an example of kind of what happens if you do it wrong. So if I put state equals New Jersey and state equals New York, you can't have both. You can't be from two different states. So what would happen is they don't overlap and you'd get no records selected back. That's what usually happens when you first start learning how to do this and you're not sure whether it's and or. Ask yourself, can I be from New Jersey and from New York? No, you can't. And they would probably tell you that. But so this is one of those examples where using and is the wrong expression. You would need or to give you back everything that's in B and C. Right now you'd get nothing back because you can't be from B and C. As you can see in the diagram here, they're separated. So unlike arithmetic operators, Boolean have no order of preference. You could do multiple conditions that run left to right. However, you can use parentheses, which I'll show you in a second, to change the order. And or an XOR are commutative, so the order doesn't matter. However, the not, which makes sense, the not is not commutative because A not B is definitely different than B not A because it's an exclusionary type of result, meaning you're getting back less data than you from the same data set. So A not B, you have to understand how to set up a not if you're going to use it. It's got to be A not B if that's what you need, or B not A if that's what you need. You can't flip flop them. It's two different, completely different data sets that you'll get back. So, like I mentioned, the order of precedence can be changed with parentheses, just like you would do in a math or any other equation. So if you look at these examples here, we have land, LU stands for land use. We have two land uses, residential and commercial. And then we have a bunch of values here, 1, 2, 3, 4, 5, 6, 7, 8. So if I look at this expression here, I have land use equals residential or land use equals commercial. Those are in parentheses, so that's going to be evaluated first. And so we're tacking on another condition, value is greater than 100,000. So what it's going to do is give me everything back. So because we have the or here, it's going to give me back all 8 of those because they're all fit within the residential or commercial. Then it's going to evaluate that data set and give me back everything that's greater than 100,000, which would give me 5, 6, 7, and 8, which is what it says right here. The second one here, we've moved the parentheses, so now it's going to give us land use equals commercial and greater than 100,000. So we're narrowing down that search right away. Okay, so it's going to give us those, and then after that, I'll say land use residential or. So that's going to give us 1, 2, because those are residential. That's this part of it. It's going to give us 5 and 6 because those are residential. But then it's only going to give us 7 and 8 because we only want the COM ones that are greater than 100,000. So that's only 7 and 8. So this is how you could change the order of precedence with parentheses. And it's pretty self-explanatory. The harder part of this is not the parentheses. It's just making sure you're using and or. A lot of times what happens is when you're, if you're comparing within the same attribute table, you're going to use or a lot, okay? Or if you're creating an inequality with values, but typically those are going to be, so we have land use here and we have land use here. That's typically going to be or because it can't necessarily be this and this within the same table, okay? Not normally. And then you use the and to sort of compare that to something outside of that, outside of that table. So it takes a little practice. It's not too hard though. Getting getting the hang of and or. Another type of query that you can run is sometimes you're going to looking for a pattern within, let's say, a text field. All right, a good example of this is, let's say you want all of the all of the states that begin with the letter M. Okay, for whatever reason, that's just what you need. What you can do is what's called partial matching or pattern matching to look for a specific set of, in this case, text within a field. So what that does is it allows you to look for things like the word stone. So that would give you back limestone and sandstone. Okay. Now that allows, what that does is again, it's another way to ask a very specific question. And another good example of this is, let's say with addresses. So maybe I need all the addresses that have the word court in them or lane, right? You can do that kind of thing with this. So it's a way of, rather than looking at an evaluation of a number or what group it belongs to, you could say I need something specific within its name, some text field that allows me to hone in on that as well. And to do that, we use what's called the like operator. You can see that here. And you'll notice it's in all capitals because it's a keyword in SQL. It has to be in all capitals. And then we use the percent sign as what's called a wildcard. Now, if you look at how this is written here in red here, you have a single quote, a percent sign, some text, another percent sign, and a single quote. Whatever is in between those percent signs is what the SQL is going to look for exactly. And that includes punctuation, spaces, and capitalization. Anything within those, it has to match exactly. So if you're looking for stone like this, it's not going to find anything with a capital S. It's only going to look for a small s, small t, small o, small n, small e. You get the idea. So if I was looking for something that, like I mentioned before, that begin with all the states that begin with the letter M, I would want to capitalize that because the states are capital. They start with capital letters. So it's very, very important that it's alphanumerically correct. You have to, use exactly what's in there. You can also, and like I mentioned briefly, you can do this with spaces, literal spaces, like if you hit the space bar. So what that would do is it would look for, some word with a space after it. If that space isn't there, it doesn't look for the word. It doesn't come back as being true. So in order to look for limestone and sandstone, because that's all one word, it's all lowercase, this is how you would write that in SQL. The single quotes also have to be there. All right, so the single quote, the percent sign, and then whatever you're looking for exactly, then another percent sign and another single quote. That is how you use the like operator. This is one of those things you really want to get good at because it makes life a lot easier when you're dealing with very large data sets, like I said, with addresses, city names. Another silly example is when you download all of the rivers for Wisconsin from the DNR, it gives you every little creek, whatever, and because I want them geometrically accurate, meaning I want them where they're supposed to be, but I only want the major rivers, what I did is I did a partial match search here with that has the word, it has a space, a capital R, and then the word river. And so that would give me back the Wisconsin space river, the Milwaukee space river, the Menominee space river. You get the idea. So you could ask questions based on capitalization, spacing, all that, as long as you write it correctly. It's a very powerful thing that saves a ton of time. The next type of query we're going to talk about are spatial queries. Now, these can be very powerful as well because you're comparing spatial relationships between two completely different layers. So some examples would be counties that contain volcanoes or counties that intersect rivers. And I'll show you all kinds of examples. Parcels within a floodplain. Hopefully you can see already that, whoa, I didn't know you could do that. We could look at that. So if you're looking at floodplains, why would you want parcels that sit outside of a floodplain? It doesn't make any sense. So this is a way of taking those two types of data. In this case, they're both the same geometry because parcels and floodplains are both polygons. But you also have counties that intersect rivers. That's polygons with lines. Counties that contain volcanoes. That's polygons with points. So you can compare different geometries and get back very nice correlations that you wouldn't have had otherwise without asking those questions. So we do this using what are called spatial operators. There's three basic types. There's the intersect, the contain / within, and then proximity. Okay, so the intersect tests whether features touch. Are they coincidental to each other? Do the faults cross this particular geometry? Do the rivers intersect counties? So they have to sort of touch each other in some way. Okay, and parcels within a floodplain. Um, Well, okay, that gets us to contains. Now, contains tests whether a feature is inside of another one, and that depends on which way you're looking at it. And the example I always give is the bucket filled with water. Am I looking, is the water, or excuse me, from the bucket's perspective, the bucket is containing the water. From the water's perspective, it's within the bucket. So they're the inverses of each other, and it depends on how you ask the question and which side of it you want to get back. And I'll explain that a bit more as we go. And then proximity tests whether features are within a specified distance. So this is essentially a buffer. Give me all of the counties, or give me all the cities within 50 miles of a volcano. That's a buffer, right? It's a distance-based proximity question. Now, if you look at some of these, there's a lot of these in here. The only ones that we're really going to deal with, but are the intersect here within a distance. Oops, sorry, within a distance of, contains, and within. All of the rest of them are very specific examples. Okay. In fact, I'll be honest with you, I've never even heard of within a distance geodesic. That's new. I don't even know what that is. I'll have to read that one. But the rest of those are all very specific examples. So the main one you're going to want to look at is intersect, within a distance, contains, and within. All right, and I'm not going to go into all the other ones because those, again, I've never used a lot of these, or they're used for very specific things. Let's say like parcel editing or something like that. So let's just focus in on those four for now. So the contains operator permits the features to lie on the edge, whereas completely contains, again, this is one of those special things, it doesn't allow you to share a boundary. So if you look at these, you're not these are very specific examples. The counties are contained within the state of, this is Oregon. So the counties are, Oregon contains the counties. Okay. Now, if the county touches the border, then it contains it. If it does not touch the border, if it's landlocked, right? So these blue counties here don't touch this black thick line on the edge. So those are completely contained by Oregon. Again, it's not gonna, that kind of stuff is very only useful in very specific instances. Now, when you're asking the question, like I mentioned with the bucket example a couple of slides ago, you have to understand when you ask the question, what do I want back? What do I want highlighted on my screen in terms of this particular query? That's where you get into understanding sort of the jargon of how to do this. When you're doing a spatial query, you have what's called the target layer and the source layer. The target layer is always the one that's going to be highlighted on your screen. Okay. So if I want back counties, counties is my target layer, and then I compare it to something else. The source layer is the one that the targets are being compared to. Okay. So for example, give me all the cities within a distance of 50 miles of a volcano. Okay. So cities are my target layer because that's what I want highlighted on my screen. I already know where the volcanoes are. I want to know which cities are near the volcanoes, 50 miles within a volcano. So the source layer is the volcanoes. It does the math. It figures out which cities are 50 miles from each volcano and highlights those on my screen. So um, the cities are the target layer. I can flip that if I wanted to, but that doesn't really make a whole lot of sense right now. So just know that counties that contain volcanoes. So here's another one. So here you'll notice the pink color on your screen, the counties are highlighted. So counties are the target layer, volcanoes are the source layer because that's what they're being compared to. You do these with what's called the select layer by location tool. That's how you execute spatial queries. It's the select layer by location tool in the geoprocessing pane. So we put in our target layer, our input feature layer. So that's what's going to be, whatever you put in that first drop down menu is what's going to be highlighted on your screen. Okay, so that's what we want back. That's our target layer. Then you need the relationship. Do we want to intersect it? Do we want to know what's contained, what's within, or within a distance of? We're going to stick to those four for right now. In this case, we're going to intersect them with our source layer, which is rivers. And now these are the major rivers in the country, not the real small ones. All right. And because this is an intersect relationship, we don't need a search distance. That would make it a proximity or within a distance of. So we don't need that, right, for this one. And the selection type is new selection, which we'll get to in a bit. That means if we're starting from scratch, we're going to ask this question first and get back an answer that's going to be highlighted on our screen. So you can see that in the graphic here, that all of those counties that are highlighted in pink there are counties that intersect rivers, the major rivers. So you can kind of get an idea of which counties are nearest to the Mississippi, Missouri, the big rivers like that. So we are testing for counties that intersect or touch the rivers. And then because counties is our target layer, which is this first drop down menu, like I mentioned, that's what's highlighted on my screen. So you got sort of a 50-50 chance of getting it right. You just have to know what you want back. Which layer do you want back? That's your target layer. Here's some more examples. So in A, we have select counties that contain volcanoes, which we've already seen. So counties is my target layer, volcanoes is my source layer, counties are what are highlighted. Select counties that intersect rivers, which we just saw in the previous slide. So you can see all the counties that intersect rivers here. And then select cities that are within 50 miles of a volcano. So here, cities are highlighted because that's our target layer. We want to know how close they are, the closest ones to volcanoes. So you could see that this is a powerful way of really honing in on data and then being able to see it visually to start to see if, there's correlations with things. Now, these are sort of broad examples, but you could take this output, these pink colored selected layers, and then do something else with them again. You can ask this data set, this subset that you have already asked, and ask that a question, which we'll get to in a second. So here's a few more examples. Select rivers that intersect Texas. Now you'll notice here in this box labeled D that the rivers actually go outside the state of Texas, which makes sense because at some time they flow and they don't just get cut off. So if you wanted it cut off, you'd have to use clip tool, which we'll get to in a bit as well. Select counties within 50 miles of a major airport. Okay, and you can see those there. There's lots of counties highlighted because there's lots of major airports. And then select states that touch Nebraska. All right, great. That would probably be easier to just click on the map, but okay, that's fine. But you get the idea. So there's lots of different combinations that you can use. The key to all of this is understanding which one is your target layer so you know what's going to be highlighted on your screen. Now, like I mentioned briefly, you can do spatial queries, okay? However, that you have to understand that it won't necessarily stop at a political boundary, for example. So if you get all the rivers that intersect the state of Texas, they don't just stop at the border of Texas. So in order to do that, you would have to use the clip tool, which I'll mention. And clip tool is used all the time in GIS. It's one of the most used tools in the toolbox. Another thing that has to be taken into account when you're doing spatial queries is logistical consistency. Okay. Now, for the data sets that you're using for this class, we don't have to worry about that. But when you go out into the real world, you have to make sure that the data set you're using will give you back the answers you expect. Because when you're comparing two data sets, if they don't line up correctly, you could get weird results, or you may not get back the results, all the results you wanted. So looking at sort of the difference between congressional districts and county boundaries, if they don't line up correctly, you may not get back the answers you work depending on the question. So for example, if you're using the within spatial operator, it may not work because the boundaries don't line up correctly. So it's important for most purposes to make sure that this goes back to downloading the data you need at the scale you need it at. So if you need it at the city scale, get it there, not necessarily the federal level, which is real jagged and not high resolution sometimes. Accuracy and precision also can play a role in this. So a good example of this is with points. We know that a city that's being represented as a point might lie along a river, like for example, Minneapolis, St. Paul, lie along the Mississippi River. But in GIS, that point may not land right on the river, so doing an intersect doesn't make sense. And you can see that in this point here doesn't lie right on there, and this point doesn't lie right on there. I did a project years ago with looking at hindrances along a river for fish. So, and then trying to get rid of them in order to allow the fish to swim upstream to spawn. So I had to physically move things ever so slightly to make sure that it landed right on my river line, so to speak. So those types of things, definitely play a role when you're doing spatial queries. Another type of spatial query is called a buffer. Now, we've seen that you can do lies within a distance of, which is technically a buffer, but the buffer tool actually creates sort of this ring feature. It creates a new polygon ring feature with its own area to delineate something specified within a distance. So, for example, ring buffer showing 100-meter drug-free zones around schools. We've all heard that, right? So that gives you sort of figure out where things are. Buffers around streams for, let's say, where logging might be off limits, or you're trying to conserve certain areas from development and things like that. So you can create buffers around points, lines, or polygons. It doesn't matter. Exclusion zones or inclusion zones, depending on what you're looking at. So the idea though is that when you use the buffer tool, you set it to what you're buffering, where you're saving it, what you're saving it as, and then your buffer field here, which it can be in any units. This one happens to be in miles. It could be in centimeters, meters, inches. It doesn't matter. The drop-down menu will give you all kinds of options for the buffer itself. But the output is then a polygon, which really comes in handy. What if I need to know how much area I need to fill in around a certain river area? um, I can run a buffer tool and then look at that and go, oh, I have this much area, so I know how much material to bring, maybe gravel or sand or whatever. So that's another way that utilizing the area fields comes in very, very handy with things like buffers. You can also take buffers and then combine that with another, let's say, spatial query that gave you an answer and combine those two as well. So you'll see that as we go, where you can combine these queries, the outputs of these queries, to get it even more specific. Remember, you're always trying to narrow down the area. So I could take that buffer tool and overlay it with, let's say, geology, and then figure out, oh, this area might need to have a certain kind of clay put on it, otherwise it's gonna, or sand or something, so otherwise it's gonna infiltrate this, or depending on what you're trying to do. So you can take the output of that buffer and use it as an input for another analysis or another intersect. Now, when you run the buffer tool, there's two options that you can use. There's what's called not dissolved and dissolved. Now, there might be a reason for using the not dissolved, but I haven't come up with one quite yet. um, so I think it's not dissolved by default. There must be a reason for it. Basically, what I tell you is if you run the buffer tool and you get back lots of little worms like this, yeah, I call them worms. There's a ton of little worms. You didn't dissolve your buffer. What you want is one big happy worm around all of it. And there's a couple of reasons for that. And the main thing is because of the areas, going back to the areas. So when you run the buffer tool, 99.99% of the time, you want that buffer dissolved. There might be reasons to not dissolve it, but I've never come up with one. But right now, just assume that you have to dissolve it. And at least in the previous versions of GIS, I haven't run the buffer tool in a while. In the previous versions, the not dissolved option was default. So you got to make sure that you change this to dissolved. All right, so I mentioned several times about the clip tool. And again, the clip tool is something that you're going to use over and over and over and over again. It's a pre-processing step. So um, if you're doing a project on Milwaukee County, and you don't need all of this data that you might have downloaded, you want to sort of chop down that data to fit the shape of Milwaukee County, and you use that with the clip tool. The clip tool acts like a cookie cutter, and it just basically comes down and cuts out exactly what you need in the shape you need it in. And that will basically chop off anything that you need. So a good example of that is typically linear features. Let's say roads, rivers, railroads, stuff like that. They don't end at political boundaries, but I need them to end at political boundaries. um, so I take my clip tool and take the shape of Milwaukee County and I chop it down, and I still get back my roads, or rivers or railroads, but I now have them in the shape of Milwaukee County. What that does is, because we're leaving our data in a geodatabase, that automatically recalculates the lengths of all those lines, and that's hugely important. So we we um, we get the recalculated length. So a good example is, let's say I'm a Milwaukee County Department of Transportation person, and I want to just get the total length of all of the roads I'm responsible for, and then I could put that into a sort of a calculator to figure out, okay, how much time am I going to need to do this? Let's say repair roads or plow, things like that. I know they have high-tech tools for that, but the idea is it would give me the total length of roads I'm responsible just by the simple fact that I use the clip tool and then save my data in a geodatabase that automatically recalculates where all of those roads have been cut off. And you can see that in this graphic on the top here. So all these roads in red have been chopped exactly at the edge of this beige polygon. And that's exactly what you want because you don't care about anything outside of your jurisdiction or your county or whatever your area of interest is. Okay. Now the inverse of that is the erase tool, which is sort of creating the outside, you're leaving all the cookie dough outside of the cookie cutter. Again, this creates sort of exclusionary zones. I've had to use this tool only a couple times, and that was sort of I had no choice. But the output of both of these tools is a new data set. So you're not messing with the original data set, which is nice. But just know that most of the time you're going to use the clip. And the clip is something that is, again, it's used a ton, especially in the beginning stages of a project where you need to get all of your data down to your area of interest. And sometimes that could be a political boundary. Sometimes that could be just some weird shape like this beige polygon that we see up here. That's sort of the city boundary. It doesn't matter. It could be a boundary that you create, a square out near Mount St. Helens, or Mount Rainier, wherever it straddles a couple of counties. You don't need all that. So the clip tool, and you use the same cookie cutter over and over again. So once you have your cookie cutter, which should be one of the first things you do in your project, once you have that cookie cutter, you use it and chop down everything to it. Your rivers, your DEM, everything should be chopped down to that cookie cutter. So when you run these tools, the extraction functions, it automatically changes the lengths or areas of the features within your cookie cutter zone. Now, for most purposes, the way we do this is we allow the program to recalculate those ourselves using the shape length and shape area fields located in your attribute table. However, if you have a user-defined field in your table, okay, if you have a user-defined field in your table, maybe my coordinate system is in meters and I need it in miles. So I create a field and I convert all my lengths to miles. If I run the clip tool or the extraction tool or whatever, any clip or erase tool, that miles field does not get updated. You have to do that manually using the calculate geometry attributes tool. So you have to rerun it because things have been chopped off and truncated. So if you allow the tool, if you're in the correct coordinate system and you're using the right units from the beginning, if you need meters or if you from the beginning of your project, it's usually not necessary to have to do this. But sometimes, every once in a while, you may have to create your own field. Let's say you're using hectares instead of acres, or some weird instead of square meters. You would have to recalculate this once you use the clip or the erase tool. So that's just a function of utilizing the power of geodatabases. If you can at all use the shape area or shape length fields, that's the way to go. So we've talked about all of these different ways of selecting data: attribute selections, query select, spatial selections, buffers, pattern selection, pattern matching. Once you have something selected on your screen, what do you do with it? Well, that's sort of the beauty of GIS is you could take those and save them and put them into another query. But one of the things you have to understand is once something is highlighted on your screen, anything you do to that data set is only applicable to what's highlighted on your screen. So for example, if I have these counties selected on my screen and I run statistics, the only statistics I'm going to get back are, yes, those counties selected on my screen. That's called honoring the selected set. Now, like I said, almost all tools do this, which makes life really easy, other than the fact that if you forget to clear your selection, and run a tool, sometimes things can get weird, but that's a whole nother story. So and I always call this one of those cardinal rules of GIS. You have to understand that once you have that selection on your screen or anything that's selected, any tool that you run, except for the clip tool that you can see at the bottom of the screen, um, will only be done to that selected feature, those selected features. And that's really handy actually, because it allows you to do multiple steps without having to reselect things all the time. So just understand that most of the time, most of the time, anything you run, any tool you run, that's going to, when you have something selected, will only be run on that selected set of data. That's called honoring the selected set. Now, there are yet more ways to select data. And one of them, another one is called interactive selection. In a nutshell, you're clicking on the screen. And there's different ways you can click on the screen in order to select things. Okay. Now, one of the caveats to this is you have to understand which layers are you selecting. And we'll talk about that in a second, but you can turn things on and off in order to make sure you're not selecting back, getting back more than you bargained for. So if you just start clicking on the screen, your mouse cursor is not as accurate as, let's say, the data, and you might select a whole bunch of things unless if you start turning off layers. So you can do things like that. By default, it's the rectangle tool, which is basically just click on the screen. You can click and drag a rectangle and it'll select anything under that rectangle, or a polygon, or sort of a lasso effect. You get the idea. I never use these. I use attribute and spatial selections. That's just me. Um, every once in a while they come in handy, but not very often. So in order to maintain this type of interactive selection, if you have like 10 layers on your map and you go to select something with your mouse pointer, chances are you're going to select a lot of stuff. And what you can do is you can turn off and turn on which layers are selectable. If all you care about are the states, if I just need to quickly click on the state of Wisconsin, I can make the states the only selected feature. I click on Wisconsin, I export it to my database, done. That's how easy it is. But sometimes the more layers you have on your map, you have to make sure that you follow that process, because again, your mouse pointer is not as accurate. You know, if you click in one spot, you might get roads, rivers, counties, states, you get all this stuff back. Now, what this also does is if you, when you're in the program, you can look at and select, view it as by selected layers. It'll tell you how many selected layers there are. So in this case, there's 2 capitals selected, 11 interstates, and these check boxes here tell you which layers are selectable. So right now, everything's selected. If I click on that screen, it'll probably select something from almost every level. I can turn these check boxes, click on them to turn them on and off. If all I need is states, I can turn off all the other ones but states. Quickly click on Wisconsin, export it, done. So this is a handy way of being able to control what is and what is not selected. Now, we haven't mentioned this before, but up until now, when you're doing either an attribute selection or a query selection, when you run that selection the first time, it's called a, you guessed it, new selection. All right. So anytime you run a new selection, it kind of drops the old one. All right. So you're running a new one and running a new one. You got it. Sometimes you got to clear your selection. You run a new one, and then from there, um, you 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 have the option of what you want to do with that selected feature. However, sometimes what you want to do is I ask a question, and then I get an answer. What if I want to ask that answer another question? So what you can do from there is you can start to piggyback your queries, both attribute and spatial. It doesn't matter. You can mix and match them. The order doesn't matter. By creating something called, most of the time you're going to use create or select subset from current selection. So I'm going to take the data I have highlighted and ask it yet another question. Okay. And so that allows you to really, really hone in on what you're looking for. And then obviously, you have to learn how to clear things and make sure you're done. When you're done with the query, you clear it, because otherwise weird things happen. The other thing is if I'm creating a subquery, or subselection, when I'm done, let's say I have what I want, I have some more data I have to get to. You want to make sure that the next time you run a query, you go back to new selection. So you have to go back to the sort of default answer. Um, and this gets a bit confusing at first because you'll forget the drop-down menu. So when you run it the first time, it'll always be a new selection. If you're going to do something to that particular selection, then you're going to either add to it, remove from it, switch, or select again from it. And most of the time, you're going to select subset. I mean, I very rarely use the other ones. Those kind of equate to the Booleans and or. They're very viable. They can be used, but typically what you're going to do is select a subset from the current selection. That's usually what you're going to do. Now, when you do this, again, it can be either, let's say I run an attribute query and I get back some selected features. Then I could take the selected features and run a spatial query with it by choosing select subset from current selection. So I can combine the two different selection methods based on my answers. Very powerful stuff. So this brings us to the Boolean, what they call the Boolean two-step. So when you're doing these, you always start with a new selection, and then you have the option of adding it to it, which is the equivalent of the or Boolean, removing from the current selection, which is the equivalent of the not Boolean, and then select a subset of the current selection, which is the and Boolean. And again, the and Boolean is typically the one you're going to use because in most cases, you're trying to restrict and restrict and restrict the data down to a very specific question that you're trying to get to. So again, that's the one you're going to use the most. These can be combined, like I said, either attribute or spatial query, to attribute or to spatial, it doesn't matter. So if I want to select earthquakes in Mineral County, Nevada with magnitudes greater than 5.0, so that's A and B. So I use the select layer by location to select earthquakes in Greene County. So that's the first thing I do. Okay. So I have to select the ones in Greene County. That's an attribute selection. Or I'm sorry, select by location, excuse me. That's a select by location. Now that's a new selection. Now I take that answer, I change the selection method to select from current selection, and then I do a attribute where it's the magnitude greater than 5.0. So that'll give me back both criteria, even though one was a spatial query and the other is an attribute query. This is something that you're going to do over and over again if you use GIS, because very rarely do you get the answer within just one data set. So you have to learn how to ask the first data set a question, kind of narrow it down to what you need, and then take that answer and ask another question, either from a different method or a completely different data set, and combine the two. So this is where it's a very powerful technique. Some of it's pre-processing where you kind of do it before maybe a full-fledged analysis, but it really does help you hone in on the very exact data that you need for your particular project. So once you have that data, like we did in the previous slide where you ask that very specific question, what do you do with the data? Well, you can make a feature layer with it and create a new layer based on the attribute query. You could make a new layer from an already selected features using a menu item. You could create a definition query where you sort of mask out everything, which I don't prefer, but the main one that you're going to use most of the time. My philosophy for GIS is isolating data. I don't like to carry around anything I don't need to. So I export those selected features to a new data set. Again, the problem with the first option of making a layer is that layer is always tied to the original data set. So they have to be moved and done, everything done together. If I'm just using Wisconsin and I do a query on, all of the 50 states, why am I carrying around all the rest of them? I don't need them. So when you run these attribute and spatial queries and the Boolean two-step and you get all your data narrowed down to the very question you're trying to ask, take those and export them as a brand new feature class in your geodatabase. That does a lot of things. It isolates it so you know what your answer is, give it a good file name. It also And very importantly, depending on what the output is, gives you areas and lengths. If it's points, you also get the points. All right. And you could take that data and then combine it again with some other data that you might have. And this is how you start building a project. So you ask the data two different questions, you get a very narrow answer. Let's say it's polygons. I could take those polygons, for example, and I can convert them to a raster and use it in a raster overlay, which we'll talk about in the next chapter, I think. Okay, so there's always a means to an end for this. A lot of this might be an intermediate step to a further goal, but you still have to run these intermediate steps. Otherwise, you're carrying around a lot of data that you don't need, and it muddies up your analysis. So the whole point of this is to get down to what you need, get it isolated in your geodatabase, and then you can use that as input to all kinds of things, either another query or an overlay or something else, and in another intersect. So these are intermediate steps, but they're intermediate steps that are hugely helpful and will get you to your goal. So although I prefer generally to export the selected features, making layers from selections is super easy and will actually do the same thing. This changed a little bit with ArcGIS Pro. So I might be kind of doing it an old way, and I might have to update my methodology because again, I like to isolate data when I'm doing projects. So making a layer from selected features is another way to preserve all of um, that data, and you can symbolize it differently. However, I'm not sure. I think you still have to have the original data set together with it. So you have to keep everything together. And that's something I'm just not a big fan of. I don't want to carry around all of the states when I only need a few of them. So just understand that there's different ways to keep your selected data sets. My personal preference is to always export them so I know exactly what the answer is. I can label the file name something, I know what it is, and use it for something else into additional tools. However, in ArcGIS Pro, this might be the new way of doing it, and I'm going to have to test that a little bit. Again, I'm learning some of this myself because I've been doing it for so long that I'm not sure if this is their new way of doing that or not. But that's it for what chapter are we on here? Chapter 9, okay? That's it for chapter 9. Um, Again, all the chapters have been reordered, so I get confused. This chapter and then the next chapter are really where you start to hone in on doing actual analysis. GIS is about finding spatial relationships that weren't readily apparent just by throwing data on a map. You have to be able to ask that data questions, both in space and based on, let's say, some type of attribute field that, you know, going back to, I just need the wells that have high iron concentrations. That's what I need for my research. So I don't care about all the other ones. Where do they sit in space? Well, I can combine that with a spatial query based on geology or, distance from a fault. I'm just throwing things out there. So all these different selection methods, none of them are hard, okay? But they're hugely important. You have to know how to use all of these and know when to use which type of selection method. The Boolean two-step thing is very, very, very easy to do and always is an option to try to really narrow down your data. Now, I didn't mention this before in the slide on the Boolean two-step, and I did forget. You can do them in any order. I could do my attribute table selection first and then my spatial selection. Okay, so I would run an attribute selection, change my methodology, change my selection method to select from current selected feature, and then run a spatial query. However, in my experience, and again, it doesn't matter, but in my experience, for whatever reason, it usually is easier to run the spatial query first. I don't know why that is. Again, it shouldn't matter, but for some reason, it always seems easier to run the spatial query than the attribute query. But again, they should run in either direction. So that's something you're going to do in the tutorial for sure, and something you definitely want to learn how to do is that Boolean two-step. And really, all it is a matter of changing a drop-down menu. That's the beauty of GIS, is everything ends up being a drop-down menu or a right-click on something. All right, so chapter 10 is our next one, which is joins and overlays. And that's where we're really going to get into, especially with vectors, how to combine things to really get at spatial relationships. Selecting features and isolating them is one thing. Then we can use that to actually perform analysis on vectors. And then chapter 11 is based on raster analysis, the same sort of thing. So chapters 9, 10, and 11 are definitely going to be getting at sort of the meat and potatoes of getting to your analysis. All right, that's it for chapter 9. See, I keep forgetting. Take care, and we'll see you in chapter 10.